All right, welcome back to the new year. Remember, this video is going to cover the things that will be on your pretest on the day that you come back from break. Remember, this is entirely optional. The pretest is going to be a diagnostic to help us understand how much of this you remember. But remember too, if you score well enough on the pretest, we'll be able to combine the score of your pretest with the quiz that you take on the Friday that you return to get you some bonus points for your knowledge. Okay, so our first rule is going to be the zero property. All right, so the zero power property. Anything to the zero power equals 1. We'll readdress this in just a little bit when we get to the quotient property. You can see in the examples here that an exponent shows up as a 0 and the resulting value becomes 1. So notice this is not written in the final form and there's nothing else that simplifies. Notice that this 0 is surrounded this entire quantity by parentheses, and therefore we would distribute this throughout, and that would mean that that is your answer. All right, property number 2. This is going to be the product property. Remember, if the bases are the same, that's going to be the key here. If the bases are different, you're going to have to make them the same before you can add their exponents. Notice here that the z's are going to combine together. Now, the thing about everything else is that we still treat everything else the same way. Notice we don't add these numbers together to get 7 or even -1. We are still multiplying. So these numbers, the bases, are being multiplied. It's the exponential properties that we're really looking at here. So don't get confused by that. This is still 12 because 4 times 3 is 12. And then it's the z's that combine together because the z's have the exponents. 7 plus 2 is 9. Here, you got to find yourself a common denominator before you begin. We like to throw in those rational exponents to get us ready for radicals in just a minute. All right, so we've got 6 over 5, that's going to give you 15, and 5 over 3, that's still going to be your common denominator of 15, and that's how we get this value here. Okay, so it's going to be fairly simple. After we find that, we just add them together. All right, down to the quotient property. We'll address this, and then we'll look at why the zero property is what it is. Okay, so if the bases are the same, again, the bases must be the same. We subtract their exponents, okay? So you're just going to look for commonalities here. Let me address this really fast. If we're using the quotient property here to explain the zero property here, all we're going to do is we're going to say that m and n are the same number. So for example, if I take this a little bit further and say it's a to the second power divided by a to the second power, the quotient property tells me it's going to be a to the 2 minus 2, which is going to be a to the 0 power. But if we go back and we address this situation very carefully, we notice that we have a fraction where the number on top is exactly the same as the number on the bottom. And that gives you the resulting number is 1. So that's why the zero property is what it is based on the quotient property. Okay, now over here to this one. What we're going to do here is we're going to look for all of the common values. So the first thing I'm going to address is the 5 minus 2. That gives me 3. Now here's what I do. I don't go ahead and look where the 5 and how to subtract these things. I just simply do this. It's 5 minus 2, and 5 minus 2 is 3. Then I ask myself, which had the bigger number of a's? Well, there's 5 a's on top and 2 a's on the bottom, which is why the a remains on top. If you want to look at it from a different point of view, you can write it out. A to the 5th is this. A squared is also this. Cancel, and then what's left is a to the 3rd, where? On top. Okay, so this is the written out version of what we're actually doing here. Okay, so again, I don't really look at what's going on with the 6, I just say, okay, there's a 6 and there's a 1, so 6 minus 1 equals 5. And then finally I say, okay, where is the bigger number of b's? Well, there's 6 on the bottom and 1 on the top, so that means in my final answer the b must remain on the bottom. And then on this one, we've got 8 to the negative 1 power. When we see the negative property in just a few minutes, you'll see how we can do this differently, but I'm going to go ahead and use the quotient property here. So I do 8 minus negative 1 equals, well, a minus and a minus makes a plus, so that's going to be 9, and that's why it's 9. Where's the larger number of c's? That's 8 on top, negative 1 on the bottom. Well, obviously they're on top, so that's where it stays. Okay? Likewise, you don't get into the habit of subtracting these numbers. Guys, treat numbers as though they're numbers. 24 divided by 4 is 6, so that means we put the 6 on the bottom. All right? X's simplify, Y's simplify, and Z's simplify. Okay? And it's the exact same way. It's going to be negative 3 minus 1. All right? And that gives me negative 4. All right? But the idea here is, well, where is it that the greater number of x's is? Oh, they're on the bottom. Okay? So 1 is greater than negative 3, so it's going to be that, 4 on the bottom. Then we get y, 3 minus 2, and that's going to give me 1. The greater number of y's is on the bottom, that's why it remains there. And then I get 1 minus minus 4 equals 5. And that's why it remains on top. All right, next property. Power to a power, very simple. You just multiply to all of the exponents on the inside. Now this gets a little bit tricky when you're looking at multiple values, okay? So we gotta be really careful about that, and we'll talk about that in just a few minutes. But notice I'm just multiplying here. So that's gonna be 3 times 1/3, which is 1. And that's how we get the exponent 1. We get 4/3 times negative 9, and that's going to be 36 over 3, and 36 over 3 is 12. So that's how I got the negative 12 there. Very simple, straightforward property there. It gets tricky when there's more than one value, so we got to be really careful there, okay? And here's where that really important understanding comes from. So I'm going to go ahead and look at this problem. So this is power to a power, but now I'm going to multiply it throughout to all of the individual values, okay? You're going to get a little bit tricked up here when we introduce the plus and minus sign, so we have to really watch this when we're looking at it, okay? But we'll address that in more detail as we move forward so that we're clear. Okay, so what I'm going to do is I'm going to multiply the 3 to all of the exponents which are inside the parentheses. I like to get in the habit of drawing exponents that are not there, so that's why I'm going to write in 1 for both the 2 and the b. So then I'm going to multiply 1 times 3 to get 3. That's how I got the 3 here. 3 times 3, that's how I got the 9 there. And this turns into 8 because this is 3 times 1, which is 3, and negative 2 to the 3rd power equals negative 2 times negative 2 times negative 2. And that's how I get negative 8 as the resulting value. Okay, the next thing I'm going to do here is I'm going to work through all of these, and because order of operations really doesn't matter, I'm going to go ahead and address the inside one first, and we'll just multiply that one through. So 3 times 3 halves times 1/9. Well, that's going to simplify down to 1/6. And then what I'm going to do is multiply that by negative 12. So 1/6 times negative 12 will give me the answer. Of negative 2. All right, moving on down. Same thing. So if you have multiplication, it works the same as if you have division. You're just distributing it to everything. So remember to get in the habit of writing in your ones so you know what you're distributing to. Writing your ones here, 1 there, and 1 there. The biggest thing you're going to do is you're going to multiply this times that, and leave this guy alone. Well, that's not true. Everybody gets treated equally. All right, so please make sure that you're doing that. Next, we've got the negative property. So what that basically means is if you have a negative anywhere in the problem, it's going to move to the opposite position of the fraction. So notice here, this is a numerator because it's on the top of the fraction. Whole numbers are always in the numerator, which means that this is going to be moved downstairs. Now once you make the move, the value of the exponent is no longer negative. It becomes positive. So don't get into that habit of making the switch and leaving the value negative. That's not going to be the correct way to solve these problems, okay? You're going to see this one pretty much in every problem that you do, so be very careful about the way that you address this situation. Notice the 5 has a 1 on it. The 1 is not negative. That means that the 5 stays put. The A is the one that has the negative exponent. That's why it goes downstairs. Remember, we're going to distribute or multiply out to all of these exponents, so don't leave anybody out. It's all about equality here. So that's why all three of the numbers move, because they're all being multiplied by a negative exponent. So review these properties, take a look at them, and be ready to do some application problems on them so that you can score well on that pretest. Enjoy the rest of your break, and thank you for paying attention.